Hey YouTube, Ed here with Jack of All Trades. Welcome to another video. Today we are going to do a video on why every time you take a piece of seasonal equipment out of storage, you can't get it to run. It won't idle, it won't run properly, it won't get any power. We're going to talk about that and why it does it and some things that you can do to fix it or to alleviate the problem. We're not going to fix the problem today, but we're going to try to avoid it. Rather than putting out a fire, let's try to avoid the fire. Before we do that, if you like this channel, you like this content, you like what I'm doing out here, please hit that subscribe button down below. Give me a thumbs up and let me know what you think about the channel, and please subscribe. Again, I always say this, I'm never asking for money. I just like to do these videos and I like to pass on information, and I'm trying to grow the channel. So I've recently reached 1,000 subscribers. Thank you to everybody who's subscribed to me, and I very much appreciate it. Now, let's talk about small engines and why every time you bring that seasonal piece of equipment out, you have a problem with it, and you end up then taking it to a mechanic or a neighbor like me who knows how to fix engines to get your equipment running so you can use it for that season. But before we talk about the why, we need to have a little bit of carburetor 101. I'm not going to get real down in depth on this, but you at least need to understand what a carburetor does, because it's usually a carburetor problem and that causes this, and you need to at least have a basic understanding of what happens in a carburetor and why you're having the problem. So let's relocate the camera. I'm going to point it down at the bench here, and we're going to have a little talk about carburetors real quick. Okay, every engine has to have some method of fuel delivery, i.e. you need to get fuel from the tank to the engine to make the engine run. If you don't have that method, the engine isn't going to do what it's supposed to do unless you've got electric, but that's a whole nother story. So we have a picture here. This is a basic diagram of a very basic carburetor. This is where the engine would be, and this is outside air. So the carburetor would be bolted up to the engine here. This is where your air cleaner would be up here. All right? Basic carburetor. Now what I'm showing here in this diagram is an engine that is not running. There's absolutely nothing happening here. The carburetor is sitting here idle. It's not, the engine isn't running. You've got fuel in your float bowl here waiting to be used. All right? Now when you start the engine, what happens is air comes into the carburetor in a very small amount because we're at an idle state right now. Air is coming into the carburetor, and what happens is at an idle, when the engine's idling, you've got your throttle plate here, and you can see your throttle plate is closed. It's actually blocking the airflow right here. So what has to happen is the air actually has to go around the edge and the end of the throttle plate, and this little port right here pushes air in here, and this is all fuel up and down in this little chamber, and what it does is it pushes air in here and it creates a little bit of pressure, and it squirts fuel out, a very small amount of fuel, on the backside of the throttle plate and allows it to go into the engine. So this is what happens at an idle. Now what you need to understand, and why I'm talking about this, is this idle circuit right here, and that's what this is called, is an idle circuit. These ports are very, very small, and I'll take a carburetor off this engine I've got sitting on the bench to show you, but the ports are basically the size of a needle point. I mean, they're extremely small. Why is that important? Because those ports are very, very easily plugged, and you can see here they're sitting here with fuel in them all the time, and that's important to understand for later. But what we need to understand is this idle circuit, these little ports around the throttle plate are very easily plugged. So if you take a carburetor off and you look on the body of the carburetor on one of the sides, you're going to see right where the carburetor throttle plate comes close to the body, there's going to be a whole bunch of little holes. Could be 5, 6, just a bunch of little holes in there, and you can barely see them. Those get plugged. And that's typically, when those get plugged off, that's typically what causes your engine to not idle. Now, when you open the throttle up, so say in your chainsaw, when you squeeze the trigger, or on your snowblower when you push the throttle lever too fast where the rabbit is, or on your lawnmower or your weed trimmer when you squeeze the trigger, whatever you're using, this throttle plate opens and it allows a whole lot more air to come into the carburetor, and it allows free-flowing, unrestricted air to come in here. Why is that important? All right, Bernoulli's principle. If you took high school physics, you learned about Bernoulli's principle. And Bernoulli's principle says anytime you increase the velocity of a gas or a liquid, you decrease the pressure. So what happens is when this air is going through the carburetor really, really fast, you can see how the carburetor kind of restricts down here, and it restricts down here, and what that does is that is increasing the velocity, but it's also decreasing the pressure. And what happens then when you open this throttle plate up is it rushes all this air through here, and as that air is rushing through, it's sucking fuel out of this jet right here instead of this jet. And that jet is much, much bigger, and it's allowing a lot more fuel, and and the carburetor is allowing a lot more air. More fuel, more air means more RPM, more horsepower, and you're actually able to do your work. Now this jet will also plug up. So if you're running your engine, and the only way you can keep the engine running is to have the choke half closed, or to push the primer bulb a whole bunch of times to keep squirting fuel into the engine, that's an indication that this main jet is plugged. Because again, that main jet is sitting there with fuel against it, and that's important, and we're going to describe that, or we're going to discuss that later. Just understand that when this throttle plate opens, more air is coming through, which allows fuel to come into the main jet, stops fuel from coming in through the idle jet, because now there's no more pressure being applied here, and it's allowing the engine to run much, much faster. Okay, so why is that important? And why is it that every time that you take your engine out of storage and you want to use it for the first time, and whatever your seasonal piece of equipment is, does it not run properly? Well, it's because this jet or this jet is plugging up. And why does it plug up? You say, why does it plug up? I've got clean fuel. I've got a clean fuel can. There's no dirt in there. We're not talking about dirt here. We're talking about crappy fuel. That's what we're talking about. And we're talking about the fact that when you put this thing up for the season, or for the winter, or for the summer, or whatever, when you put it in storage, there was all this fuel still left in here, and what happens over the course of time is fuel actually degrades, and it gets bad, and it gets sludgy and gross, and you can actually tell if fuel is old by the smell of it if you've done it long enough. It's got a really rancid odor to it. It's really disgusting. But what happens is the fuel starts to evaporate, and it starts to get thicker, and then subsequently it will plug up these jets. And then you bring it out in the spring and you try to run it, and the damn thing won't idle and it won't run, and then you get mad, and then you take it to a mechanic and they charge you $500 to clean your carburetor or to replace your carburetor, or you take it to your neighbor, like most of my neighbors do, and fix it, and then everything runs just fine and well and good. So what is happening is all this fuel that's in the carburetor is degrading, and it's going bad, and it's plugging these jets up. And that's what's causing probably 75 to 80% of your problems in the spring or in the fall when you take that seasonal piece of equipment out to use it. So what I'm going to do here is I am going to actually remove the carburetor off of this, and I'm going to show you where those idle circuit ports are on this particular engine. Now this is a Briggs & Stratton engine. I'm going to show you where the idle circuit ports are, and I'm also going to show you where the high-speed fuel comes in on this carburetor, so you've got an idea of where those are and what you're actually looking at. Here's the carburetor. Now, this is the air inlet side of the carburetor, and this is where the choke is. So when I run the choke, it opens and closes the choke. On the other side is the throttle. So as you speed the engine up, to speed the engine up, you open the throttle. Right here are the little fuel ports that I'm talking about. And you can see I've got this pointer sharpened to real fine point. You can see how small those ports are in comparison. And if I open the throttle up, you can see there's a bunch more right in here. Those are all related to your idle circuit. And if any one of those are plugged, your engine's not going to idle. It's not going to idle at all. It's going to idle very, very poorly. So that's what causes your engines to not idle correctly, is that these typically get plugged. Fuel, as it degrades, will get sludgy. It'll very easily plug up these ports, and then it'll subsequently plug up all the passages inside the carburetor that feed these ports. So if I take the float bowl off, this is the float right here. Right in here, in that hole, is the main jet that feeds the fuel when the engine's running at wide open throttle or partial throttle. So if I open this throttle up, that fuel is fed right through that little brass tube down inside there. It's very, very hard to see, but believe you me, it's there. There's a little brass tube there. It's called a metering tube, and that's where all the fuel flows out. So if that gets plugged, you also have a problem. Now that jet is actually removable and it's replaceable. I'm not going to take it out because there's actually nothing wrong with this carburetor. This engine runs like a watch. But if you plug that up, and if you clean that and you clean that, you can oftentimes alleviate a lot of your problems. But we'll go over that. We'll go over repairing a carburetor on another day. I just wanted to reiterate to you how small those holes are. Where you can see right there is where the throttle closes. That larger hole right here is where the fuel actually comes out to make the engine idle. These holes here actually control the airflow, and a little bit of fuel comes out of those as well. But you can see how tiny those holes are, and it doesn't take much to plug those up. All right, so now that we know how a carburetor works and we know how susceptible these things are to plugging up, how do you keep them from plugging up when you put these things in the long-term storage? Well, there's a couple of ways to do this. The best and most effective way, and you really can't beat this, is to drain it. You drain your fuel system completely. Now, if you have a lawnmower or a snowblower, the fuel tank is attached to the machine. There's no way to unplug it. There's nothing like this. So you basically would have to pull the fuel line off and drain the tank out and then run the engine until the carburetor runs dry. Draining the fuel system is the best way to make sure that your carburetor doesn't plug up. However, that may not work for everybody. And maybe you're not very mechanically inclined and that's not your thing. That's very possible. I can't bake cookies, but I can fix an engine. Cookies are not my thing. Engines are not everybody's thing. So how do you do that without having to drain the carburetor? The best way to do it is to use good fuel, fill the tank to capacity, fill it right up to the top, and use some kind of an engine or fuel stabilizer if you have to. Now you can see I've got some gas cans here, so let's talk about gas a little bit. So I've got 4 different types of fuel here. This is all fuel that you can buy in the store or you can get at your standard gas pump. Okay, this fuel is E85. E85 fuel is a fuel that is 85% corn alcohol or alcohol made from some kind of a plant derivative. This fuel is only to be used in what they call a flex fuel vehicle. That means it's a vehicle designed to burn E85 fuel. I am here to tell you, your lawnmower, your snowblower, your weed trimmer, your chainsaw, your ATV, your boat motor, anything like that is not designed to use E85. The only vehicles or the only engines out there right now that are designed to burn E85 say flex fuel compatible on the machine somewhere, and they're typically a car. So don't even consider putting E85 in your small engine appliance or tool or whatever. Don't even do it. So we're just going to take that right out of the picture. E85 is not an option. 87 octane with 10% ethanol is extremely common. Extremely common. This is okay, and it's only okay under a couple of circumstances, and that would be, one, you intend to run it out of fuel when you're done with it. You're not going to store it with this in there. Or two, you are going to be absolutely certain that you add a fuel stabilizer to it, and that you know how to properly mix your fuel stabilizer, and that you run the engine to get the fuel stabilizer circulated throughout the fuel system. It doesn't do you any good to put fuel stabilizer in the tank if you don't run it through the fuel delivery system of the engine. So you need to put fuel stabilizer in the gas tank of the appliance, run it, make sure that fuel stabilizing product gets circulated throughout the fuel system, and then shut it off and store it for the winter. You can get away with this. I still don't like 87 octane with 10% ethanol. These small engines are not designed to run with alcohol. The gaskets and the seals and the rings and the O-rings and things like that, they're just not. Small engines are very inexpensively built, and they're just not designed to deal with ethanol. So I generally shy away from anything that's got ethanol in it, period. I don't burn ethanol in any of my small engines, so I like to push that aside. So that leaves us with 91 octane no ethanol. You can buy this in the pump, and this is what I burn in all of my small engines. This goes into my ATVs, this goes into my boat, this goes into my chainsaw, my weed trimmer, well, not my weed trimmer, my chainsaw, my snowblower, my lawnmower, my generator, anything that's got a small engine in it uses gets 91 octane, no ethanol, and I do that without exception. I also, on occasions, use True Fuel. I really like this stuff. This is what I primarily use for my chainsaw, though I do use this in my chainsaw, and I'll mix it if I'm doing a lot of cutting, and I know I'm going to be doing a lot of cutting because it'll save you a little money if you pre-mix with pump gas. But if I'm just looking for a very convenient way to get fuel for my chainsaw, this I really, really like. And the other thing I like about True Fuel is it's actually designed around long-term storage. In other words, if you're going to store your machine with fuel in it, it's best to fill it up with something like this because it's designed for long-term storage because it has no ethanol in it. So let me show you this. It says right on the can, ethanol free, excellent for long-term storage. And then if you go over here and you look, 92 octane with no ethanol. That is the key factor right there. No ethanol. The 92 octane is very good too, and don't get me wrong, that's a nice feature and that's awesome. No ethanol is the key. So this stuff runs you about $7 for that can right there. It's 32 fluid ounces. It runs you about $7. You can get it a 40-to-1 or a 50-to-1 mix. The 50-to-1 mix can is a red can. The 40-to-1 is a green can, so you really can't mix them up. I really like this stuff. I put this in my weed trimmers and my chainsaws because it is really hard to drain the fuel system on either of those. So I just fill the tank up, and I always burn, if I can, this product. If I use this with a mix, if I'm going to be using my chainsaw and I'm going to be cutting a lot, if I've got trees to fell and I know I'm going to go through at least a gallon of fuel, I'll mix it with this because this is about $7 a quart. I believe that's a quart, yeah. So it's about $7 a quart, whereas this is much, much cheaper. It's about $3 a gallon, and then I just get a very good two-stroke oil to mix with it on a 40-to-1 ratio. But this is a product I really, really like. And if you don't want to have to deal with mixing, this is an excellent product. I really can't find a claim on shelf life on this, but I would have absolutely no problem storing this in my chainsaw or in my weed trimmer for the course of a winter until spring comes and I want to run it, and then just run this in it all the time. All right, so we've talked about fuel a little bit, and I've tried to impress on you that no ethanol is the way to go. And talk to any good, competent small engine mechanic, and they're going to tell you the same thing. They always say you can get away with 10% ethanol, but they really highly recommend that no ethanol is what you burn in these engines. So I exclusively burn nothing but no ethanol fuel in my small engines, and I've had way less problems with carburetors and how the machine runs due to the fact that I'm using this kind of fuel. Now, I've done kind of a neat little thing. I've got, well, let me just take you over here and I'll show you. All right, so what I've got here is I've got 5 little craft paint dishes. I bought these at Hobby Lobby, I believe. So what I've got here is I've got 4 different kinds of fuel in here. This is E85. This is 10% ethanol, 87 octane. This is 91 octane, no ethanol. This is True Fuel. And that is denatured alcohol. It's not even gasoline. It's denatured alcohol. I bought it at Walmart. It's made by Clean Strip. And I'd like you to just take a look at the colors. And you can see the alcohol is almost clear. The E85, actually, excuse me, this is E85. It's almost clear because there's only 15% gasoline in here. The rest of it's all alcohol. That's why it's so cheap. This is the denatured alcohol. You can see they're almost exactly the same color. Pretty crazy. True Fuel, which is this right here, has got a green tinge to it. And that's because there's an oil mixed in with it because this is to run a 2-stroke engine. This over here is the 87 octane with 10%. And this here is the 91 octane with no ethanol in it. And you can see there's even a color difference in between those. I just thought it was very interesting to see the color differences in the fuel. And you can see that this one is E85 is almost all alcohol, and it doesn't look any different than denatured alcohol. So you can see you can tell that you wouldn't go dumping denatured alcohol into your small engine because you know it's not going to run right. It's got a different burn rate. It's a colder burning. It just is not set up and designed to run on E85 fuel. So just don't do it. If you see E85 on the pump, don't put it in a can. It's that simple. So this is a close-up of the 87 octane with 10% in it, 10% ethanol in it. And if you look at the top of the pan there, you can see a blotchy color or a discoloration that's different than the rest of the fuel. And that's actually the alcohol separating away from the fuel. And that's another problem with small engines that sit for long periods of time and using 10% ethanol fuel is that the fuel will actually start to separate out from the ethanol, and it just creates a myriad of problems. And so that's just one more reason why I always insist on not using any ethanol fuel in small engines. All right, so now what I'm going to do is I'm going to take you outside, and I've got a Predator 6500 generator that I've got from Harbor Freight. I've had it for a few years now. I run about once a month to just get the gas circulating, get the oil circulating. I change oil on it a couple of times a year, and I keep it around for emergency purposes. A storm comes through, knocks out the power lines. We're at least going to have power in our house. So what I'm going to do is I'm going to take you outside, and I'm going to wheel that generator out. I haven't run it in a little over 30 days. We're going to start that thing up, and I'm going to it should start up right away. If fingers crossed, if all goes well, it should start up right away. And the way I store that is I shut the fuel valve off and I drain the carburetor out of fuel. And I'm going to show you that process. And the process is essentially the same with pretty much any engine. The only difference would be is if your engine's got a primer bulb on it, you also have to actuate the primer bulb as the engine starts to run out of fuel and starts to sputter, and you can hear it just to make sure that the primer bulb is empty as well if you're going to do a full engine drain. So let's relocate the camera. Let's take you outside, and let's get that generator run up, and then I'll show you how I shut it down. All right, so the first thing I have to do is right here I have my fuel shut off, and as you can see it's in the off position. Here's the diagram, it says off position. Turn my fuel on. I'm going to let it sit for a minute because what has to happen is fuel has to drain out of the tank and refill the carburetor bowl because it's been sitting empty. Now here's my choke, and I have to put the choke to the start position. Now I want you to see something. I want you to look at something while I'm waiting for the carburetor bowl to fill up. No E85. 10% ethanol blend, okay. It's just okay. Gas only, 10% ethanol, okay. No E85. I can't stress to you how dumb it would be to put E85 in your small engine. Just don't do it. All right, now that it's been sitting for a minute, let's see how it starts. Can you even believe it? It started on the first pull. I brought you back into my shop because it's a little loud out there. It started on the first pull, and I hadn't run it in several weeks. So that's pretty good. So that tells you that the process that I'm doing is working very, very well. And you can hear that the engine is running like a kitten. It's just purring along. Now what I'm going to do is I'm going to do a shutdown on it. And I'm going to shut it down the same way that I would shut down for long-term storage. And what I'm going to do is I'm going to turn the fuel off at the fuel shut-off. And then when I hear the engine start to sputter and spit, I'm going to feather the choke to make sure that all the fuel is drained out of the carburetor. And I had to tell you this ahead of time because when I'm out there and the generator's running, it's going to be really, really hard to hear. So now I've shut the fuel off, and it's going to take some time. It's got to drain out all the fuel out of the carburetor, and then it's got to drain all the fuel out of the bowl and suck it through, and then I'm going to have to clear out the choke system. So you can hear it's just starting to oscillate. That's because it's running out of fuel. So now I'm going to turn the choke on a little. I just turned on the choke a little. So now the engine's basically running on a half choke. And there it's run out. It's out of fuel. All right, so there you have it. Started up on the first pull. This generator gets nothing but 91 octane ethanol free in it. And I do that fuel shut off procedure every time I put it up for storage. And it never fails me. I've had this generator for going on 4 years now, and I've used it a few times for camping and things of that effect. I've used it a couple of times to run my portable welder out in the field where I didn't have any electrical power, and I used it once to power my house when we had a shutdown, power shutdown, and it wasn't a very long shutdown, but I wanted to try it out, and it works. So you can see that the process works. 91 octane ethanol free fuel, and doing the proper shutdown on it or draining the fuel system has never let me down. Knock on wood, it's never let me down. So that is always the process I recommend to everybody if possible. So I hope you found this video informative. I hope it's useful for you. If you have any comments or if you have any discussion about it, I'm all ears. If you've got a different process that you use that works good for you, please let me know about it. I'd love to hear it. This is the process that works for me, and it's never let me down yet. So this is Ed with Jack of All Trades. I appreciate you riding along with me, and we will see you on the next video.